There's some technical safety challenges that need to be addressed in these vehicles. For assistive, we should see more uniform adoption of safety standards such as ISO 26262. The automotive industry is the only industry I'm aware of in which there's a mature safety standard, but the companies building the product do not publicly say that they conform to the standard. As this technology becomes more highly automated and people become more dependent on its correct operation for safety, it will become increasingly important for the industry to conform to established safety standards. For supervised automation, it's important to realize that safety credit is given if there are low false positives. So that means if 19 times out of 20, an active safety system saves the day and prevents a crash or prevents injuries, then the ADAS system is going to get the credit. The active safety wins if even only 19 times out of 20, even only 9 times out of 10, it does the right thing and saves lives. That's a victory because the driver was not supposed to make the mistake in the first place, and it's saving the driver from a mistake. It is, however, essential to have effective driver monitoring because automation complacency is a real issue, especially with the higher levels of automation involved in driving. For automated driving, in which the vehicle actually does all the driving task, not a human driver, then it's going to be increasingly challenging to do safety of the intended function, especially scenario completeness and coverage. Because at this point, if there's any gaps in things the vehicle knows how to do, it's the vehicle's problem because it's fully in charge of driving. The specific challenges here are sensor fusion, perception, and prediction. But an additional challenge for social acceptance is that, unlike supervised driving, in which any automation features get credit for saving the driver, in fully automated systems, the automated vehicle gets the blame. If it's not 100% every time it causes a crash by not being perfect, it gets the blame because there was no driver to blame and no driver responsible for the crash. It's all on the automation. And so that means for automated driving, you need not only low false positives to get good permissiveness, but for every false negative that results in a crash, the automated system gets blamed. So the emphasis isn't on getting a pretty good blue slice of the pie here. The emphasis is you get blamed even if that red slice is a little tiny sliver. If it's not better at least than a normal human driver, then that's a problem. And for autonomous, you have to do even more than just driving. You have to take full responsibility for every aspect of vehicle safety. UL 4600 goes on about this at length. But the takeaway here is drivers do more than drive, and you have to cover all those bases if you want to actually build a completely autonomous vehicle that's safe.